everybody, Miss Wallace here. We are starting a new unit this week, and this unit is called Changes to Earth's Surface. We're also going to be talking about fossil fuels and natural resources. I just wanted to go over a little vocabulary with you that's really critical that you know and understand with this unit. So I'm going to take some notes here on my page. You're welcome to do that on your page as well, because you really do need to know this vocabulary. So the first one that you see here, it's wind, water, ice. And what these are forces of nature that are going to lead to weathering, erosion, and possibly deposition. And we're going to talk about those terms later on. Forces of nature that can cause, my computer has a little bit of a lag here, can cause weathering, erosion, and deposition. So what does that mean as far as changes to Earth's surface? That means that as we break things down, as things are weathered, we're going to change the surface of the Earth. As things move across the surface with erosion, that's going to leave a path and make the Earth's surface look different. And then deposition, the dropping off of those sediments, okay? So the picture that I put over here for you is actually a glacier. You can see it coming down the mountains. And we know that glaciers are extremely powerful. Lots and lots of ice, really, really heavy. And so as this glacier moves down through this valley area, it's carving out, okay? It is actually picking up rocks and sediment along the way. And as it gets here to the ocean, and typically we see it melts here, it's going to be dropping those sediments off. So it's going to break the rocks down, that's weathering. It's going to erode it, meaning it's going to carry it down to the mouth of this glacier here and erode it, and then it's going to deposit it. Okay, so wind, water, and ice are our three forces of nature that can cause these. So let's talk about a sand dune. I want you to think about what force forms sand dunes. So we're going to say force, and what do you think? Do you think it's wind, water, or ice? Probably not ice, because we don't see a lot of ice in the desert. You can have sand dunes in areas that aren't necessarily a desert area. There's actually sand dunes in Colorado. So this would definitely be wind. Okay, wind is going to cause sand dunes. And so the wind is going to pick up sediments and blow them across an area, then deposit them. Okay. So the wind's going to pick up the sand. It blows the sand until the sand hits an area. Maybe it's a new sand dune that's building up. The sand falls out of the wind, and now we have a new sand dune. Some people will say that the desert seems alive, because if you come back, you take a picture one day in a certain spot, you come back a few weeks later in that certain spot, it looks completely different, because the sand dunes have actually shifted and they've changed. All right, let's look at a delta. So we see deltas usually form at the mouth of rivers, which means it's where the river is going to dump into the ocean. So let's think about the force here. The force would be water, because we're talking about a river. And these form at the mouth of a river, where the river dumps into the ocean. And what happens, the river is picking up sediment along the way. All right, it's eroding it, meaning it's carrying it along. And as this fast-flowing river gets to the ocean, it slows way down. And because the velocity of the river slows down, it starts dropping all the sediment out of it. So you see kind of this portion right here that's green, kind of in a triangular shape. Most deltas form in a triangle. That's actually the Greek letter. Delta is a triangle symbol. And so what's happening is really the land is extending out into the ocean over hundreds to thousands of years. You see new land forming because all these sediments are being dropped off here at the mouth of the river. What also happens is over time, when these sediments build up, it forces the river to sometimes change direction. So where we see that we have the large part of the river coming out here, maybe in a few years, it starts splitting and comes over to a different area because this area has built up with sediments. Kind of dams up the river in locations. So this is a river delta. Okay. All right, let's look at the valleys. We have two different kinds here. We have the V-shaped valley and a U-shaped valley. So the force for a V-shape valley is going to be water. And again, it's going to be a river or a stream, typically fast flowing. So the river weathers and erodes the sediment, carries it downstream until it dumps into the ocean or wherever, and it leaves a V shape behind. And so we see that here. We can see that pretty steep hills on each side. It's a pretty definite V shape, okay? And here's how I want you to remember this. The word river has a V in the middle of it, okay? So when you see that V in river, I want you to think V-shaped valley, okay? So then let's come down here to the U-shaped valley. You can tell this is a definite U shape. It's carved out a lot more. And so the force here is actually going to be ice, and it's specifically a glacier. So kind of like that picture that I showed you up here with wind, water, and ice. Over time, if this glacier completely melts away, this is what would be left behind. It would be a U-shaped valley. So the ice is going to weather and erode sediments and carves a V shape, U shape, okay, a U shape in that area of the land. And so here's how you remember this. The word glacier has a C in the middle of it, okay? And if I turn that little C on its back, it looks like a U. And so that's one way you can remember. Glacier is going to carve a U-shaped valley. River is going to carve a V-shaped valley, okay? Two different forces. We have a river or water here. We have ice or a glacier here, okay? Scroll on down to the next one. This is a canyon. We always think of the Grand Canyon, right? Which is our biggest canyon here in America. And in the canyon is the Colorado River. And so we're going to see a river here, right? So water is going to do it. Put that in parentheses. Water. And it is going to carve out land by weathering and eroding. And it leaves behind steep walls. Okay? A little bit different than what we see in a valley, okay? And usually that has to do with the type of sediment or the type of dirt that you have in this area, whether it's going to carve it into a valley or a canyon. Typically a very fast-flowing river is going to carve a canyon. Your slower rivers may carve the valleys. All right? So when we talk about these different landforms, you hear me saying a lot of times weathering, erosion, deposition, because those happen over and over and over again. And so we cannot do this unit without knowing what these terms are. So weathering, I want you to think of as breaking down, okay? Breaking down rocks into sediments. If you've ever looked really closely at sand, you probably saw that it's made up of really tiny pieces of rock, and that's what sediments are. It's just a bigger rock that's been broken down into a smaller rock. We see here in our picture example, we have this large piece of land, but over time, the waves have weathered or broken down this large rock, and they've carried away those sediments, okay? So breaking down is weathering, okay? And so if you think of your hand when you make a W, like you put up 3 fingers, looks like a W, then I want you to think weathering or breaking down. The next one is erosion. And so the picture I put here is kind of like a sandy hill, and what's happened because of water has eroded. It's taken the sand from here and it's brought it down and deposited it in new areas. So erosion is the movement of sediments to a new location. So I can get my fingers to work. Okay, so the movement of sediments to a new location. So keyword here is movement. When those sediments start to move, that's what we're going to call erosion. Okay, weathering is breaking down. Erosion is the movement of those sediments. And then I put another picture of a delta here. This is a really cool picture because you can actually see these sediments being brought down by the river and how they're just being dumped here into the mouth of the river there at the ocean. So this is the dropping off of sediments. Okay. So keyword here is dropping off. So this usually happens when things slow down, when the river slows down, when the wind slows down, whatever it is that's doing the eroding, when it slows down, that's when sediments are actually going to drop off. Okay, that's kind of easy to remember because we see the D here in deposition. We're thinking the dropping off of the sediments. Okay, now we will talk a lot more about compaction and cementation kind of as we move through this unit. But compaction is going to be the pressing down of layers of sediments on layers below. And when you have compaction, just think of a trash compactor, right? Trash compactors and squeeze all that trash together to make room for more. So the picture I put here, see all these layers, and it's like these layers on top have pressed down on these, and it forms really tough, hard layers. When you have compaction, it's going to give you heat. This is going to be critical when we talk about fossil fuels, heat and pressure. So these layers deep down in the earth are going to experience a lot of pressure and also a lot of heat. So when we compact things, we're pressing those down, okay? So when we talk about the formation of sedimentary rocks, we'll talk more about compaction. When we talk about fossil fuels, okay, we'll talk more about compaction. Cementation, this is a really cool process. So what happens over time, you've got all these layers, right, that have been compacted down. Water can actually find its way through some of these layers. And so water is going to trickle through layers of sediment and leaves minerals behind. And so water is going to trickle through these layers, and it leaves these minerals behind. And these minerals act like glue. Minerals act like glue. And what happens is you have all these tiny little pieces of sediment, and they literally get glued together from these minerals. And this is how we get a sedimentary rock. We get a new rock that is formed. So you see this part that says cementation. I want you to think of cement. Okay, it's really sticking it together. And so cementation is where we're using those minerals to stick all these little sediments together. Now, last one here is a really cool process. This is probably my favorite one to look at. We have ice wedging and we have biological wedging. So in ice wedging, this is a form of weathering. We need to put that in here. Remember that weathering is a breaking down of rock. So here you have a rock. Let's say it's got a little crack in it. Over time, it rains, that water gets down in there. Well, if this rock is in an area that's going to get below freezing, we know 0 degrees Celsius, and that water freezes, what does water do when it freezes? It expands. And so that water has gotten down in the rock, it freezes, it expands. It actually will bust that rock apart, okay? So it breaks it apart. So you see here, this is a big rock, okay, in this picture. Water has gotten down in here, probably in a little crack at the top, and over time, it's worked its way down until it's actually busted the rock apart. So it's a type of weathering. Water or roots. Roots can do the same thing. You can, maybe even go out in your backyard, go in an area here in Emory and find trees that have even like the roots have busted up the concrete at the sidewalks, or it's busted up some large rocks that you might see. So water or roots penetrate, go into, and break them apart. So super cool process here. Ice wedging is where it would be with ice. Biological wedging would be where we have like the roots from trees or bushes that are actually breaking them apart. Hope you find this stuff interesting. I really enjoyed this unit. There's lots of cool pictures to look at and things that we'll be studying. Let me know if you have any questions.